Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to learn how to graph parabolas that have horizontal axes of symmetry. So we've graphed parabolas of the form y equals x squared. Now we're talking about x equals y squared, and it's going to give us a parabola that either opens left or right rather than up or down. In general, the form looks like this. If we have something of this form, x minus h equals a times y minus k quantity squared, this is a parabola that will either open left or right. The vertex will be at the point hk, the number being subtracted from x, comma, the number being subtracted from y. The value of a lets us know whether this is opening to the left or to the right, depending on whether a is negative or positive. And that's one of those stretch factors that we've talked about before. So we've got a couple of examples in this video. The first one is x minus 1 equals negative y minus 3 quantity squared. So the first thing I get is that my value of h is 1. That's what's being subtracted from x. And my value of k is 3. That's being subtracted from y. So the vertex is at the point 1, 3. Over 1, up 3. Next, because the value in front of the squared term is negative, this means that it opens to the left. So it's going to go from that point out to the left. And depending on the book and the instructor that you have, you may only be asked to sketch these. You may be asked to graph them in full by finding any intercepts. So I'm going to go with the full approach, but what I know for sure is that the graph is going to look something like that. We'll try to make it a little more precise by finding the intercepts and so on. So the first thing I'm going to look for, since I know that it opens, since I know it opens to the left and the vertex is to the right of the y-axis, it has to have y-intercepts. So I'm going to find the x-intercepts. I'm going to find the y-intercepts, like I just said, by letting x equal 0. So y-intercept, where x equals 0, that's going to be 0 minus 1 equals negative y minus 3 squared. Negative 1 equals negative y minus 3 squared. Multiply through by a negative 1 to change the signs. 1 equals y minus 3 squared. Now we can take the square root of both sides. Square root of 1 is 1, so plus or minus 1 equals the square root of that binomial squared is just that binomial, y minus 3. So y equals 3 plus or minus 1. 3 plus 1 is 4. 3 minus 1 is 2. So it's going to have y-intercepts at 4 and 2. I could also find the x-intercept, which is where y equals 0. X minus 1 equals negative 0 minus 3 squared. X minus 1 equals negative, or the opposite of negative 3 squared. X minus 1 equals negative 9. And then if I add 1, I get x equals negative 8. So I've got a point here at negative 8. And I know now that my axis of symmetry goes through y equals 3. So that point is 3 below. I can add another point that's 3 above the axis. 1, 2, 3. Like that. Something like that. Now, in terms of domain and range, everything flips around from the types of parabolas we've learned how to do. The domain, if we read this from left to right, is negative infinity, comma 1. It goes all the way to the left, but it only goes to 1 on the right. The range, because we have an arrow moving slowly up and slowly down, it's still moving up and down. The range is the set of all real numbers. So that's how we graph a parabola, getting a little ahead of myself, a parabola that opens to the left or right. And what really tells us to watch that it's this type is which variable is being squared. If x is being squared, it's up or down. If y is being squared, it's left or right. Let's take a look at one more. This one's going to be a little more difficult because it's not in the right form, but I do see a y squared, so I know it's going to be left or right. And the coefficient of that y squared is positive, so I know it's going to open to the right. But I need to complete the square to make this happen. So let's start there. X equals 2 times y squared plus 4y, and then plus 3 outside the parentheses. I need to take half of the y term's coefficient, square it, and add it inside the parentheses. Half of 4 is 2, squared is 4. Oops. So I'm going to add 4 inside the parentheses, but that's really 2 times 4 because of the factor of 2 that's out in front. So I've added 8. That means I need to subtract 8 to keep that equation in balance. X equals 2 times y plus 2 squared minus 5. And I'm going to bring that 5 over to the left-hand side so it's in that same format that we used in the first one. X minus h equals a times y minus k squared. So the equation is equivalent to x plus 5 equals 2 times y plus 2 squared. H is negative 5, k is negative 2, because those are the values being subtracted from x and y. X plus 5 is the same as x minus negative 5. Y plus 2 is the same as y minus negative 2. That's how we figure out h and k. A is 2, so that means that it's going to open to the right, and that 2 is a stretch factor, so this one's going to move to the right a lot faster than the first one we did move to the left. All right, vertex, negative 5, negative 2. It's going to go to the right, so we know that it's going to have y-intercepts. They all of the ones that open left or right have to have an x-intercept. Maybe we'll find that one first. The x-intercept where y equals 0. I can plug into the one that I just found, but I could also go way back to the top, right? And do x equals 2 times 0 squared plus 8 times 0 plus 3. X equals 3. So the x-intercept is at 3, 0. Right there. I know that the axis of symmetry goes through the vertex. So it's at a height of negative 2. That x-intercept is 2 units above it. So I can add another point that's 2 units below it, but with the same x value. We know that the parabola, when we moved, for the vertical ones, when we moved up 1, when we moved out 1, we moved up 1. With this factor of 2, when we move out 1, we're going to move up 2. So I could get another pair of points there. I could also get that by plugging in, say, negative 3 for x and solving. Or I could plug in those values of y. If I plug in negative 1 for y, I'm going to get negative 3. And if I plug in negative 3 for y, I'm also going to get negative 3. So more points makes it easier to plot. I should find those y-intercepts, though. The y-intercept where x equals 0. And I'm going to use the second equation to do this one. 2 times y plus 2 squared equals 0 plus 5. 0 plus 5 is just 5. I'll divide over the 2. Y plus 2 squared equals 5 halves. Take the square root. Y plus 2 equals plus or minus root 5 halves. Subtract over the 2. Y equals negative 2 plus or minus root 5 halves. And then I can approximate this with a calculator. I could also clean up that radical, multiply top and bottom by 2, so I can get the denominator out of the square root. Since I'm only approximating this, I can go to the calculator as is. And I know that 5/2 is 2.5, so I could use that as well if I wanted to. Let's go to the Desmos calculator. Here we go. So it was -2 plus square root fraction 5/2. And I can see that's about -0.4. If I change the plus in front of the square root to a minus, now I've got -3.6. So I've got approximations for both of those y-intercepts, -0.4 and -3.6. -0.4 would be about here, -3.6 about here. Now I've got a lot of points. Help me draw this. Something like that. This time, the domain, how far to the left does it go? -5. How far to the right? Forever. That's infinity. And the range, arrows going up and down, the range is all real numbers. All right, so that's a quick introduction to graphing parabolas that either open to the left or the right. In the next video, we're going to talk about a different type of definition for a parabola.